Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 7 from the Solomon A Mechanics M1 paper, which also corresponds to question number 3 from my end of topic worksheet on forces and friction. This question here is about these connected particles on this plane here, and you've got an inclined plane on one side, an inclined plane on the other side. One of them is an angle of 30 degrees, the other one an angle of 60 degrees. This figure 3 shows a particle X of mass 3 kilograms on a smooth plane, means we don't have to worry about friction, inclined at 30 degrees to the horizontal, and particle Y of mass 2 kilograms on a smooth plane inclined at 60 degrees to the horizontal. The two particles are connected by a light inextensible string of length 2.5 meters, passing over a smooth pulley at C, which is the highest point of the two planes. Initially, Y is at a point just below C, touching the pulley with the string taut. When the particles are released from rest, they travel along the lines of greater slope, AC in the case of X and BC on the case of Y, of the respective planes. A and B are the points where the planes meet the horizontal ground. Okay, and AB equals 4 meters. All right. Show that the initial acceleration of the system is given by this formula g over 10 times 2 root 3 minus 3 meters per second squared. So let's put all the values here that we have. So we have the forces acting on these particles. You have the weights of these particles. Okay, acting vertically downwards. So this is 3 g newtons and this is 2 g newtons. Okay, you have the reaction forces, which are acting perpendicular to the plane. So this is the reaction force at X, and this is the reaction force at Y. All right, so those are the forces. You've got the tension acting, pulling that up, and kind of pulling on that up this way. So those are the tensions acting on the particles. And this is going to accelerate in this direction. This is going to accelerate in this direction. The magnitude of the two accelerations are the same because the string is an inextensible string. Now, we have to basically now resolve the forces parallel and perpendicular to the plane. We're only really worried about parallel to the planes here because there's no friction, so we don't worry about mu r or anything like that. But we need to resolve the forces parallel to the directions in which these objects are going to move. So I need to resolve this force parallel to the plane here. So I'll just draw it with a dotted line. This is resolving this 3g force in this direction. I need to also resolve this 2g force in that direction. Okay, now how do we do that? Now there was a question asked to me just I think yesterday, and the student didn't understand why the angles that we use were what they use. So I'm going to go through a little bit of an explanation here about why the angles that we use are what they are. So what I'm going to do is I'll just extend this line a little bit to make it a bit clearer. Okay, I'll write this down here. Now, basically, I need to know what this angle here is so that I can resolve this force parallel and perpendicular to the plane. So I need to find what the angle here is. Now, a lot of people memorize that it's 30 degrees, but why is it 30 degrees? Well, it's due to similarity. Okay, this is a line which is perpendicular to this plane. So you see you have a triangle here that looks like that. Okay, this is that right angle over there. This is 30 degrees. Okay, so that's this triangle over here, right? This big triangle here. Now, you also have a triangle over here, this triangle that we've just drawn. Okay, now this is 90 degrees. Okay, and this angle in this triangle here is the same angle in that big triangle there. So this angle here is the same angle as the angle on this side here. They're both the same. You see, this is in this big triangle here. It's also in this small triangle here. All right, so those two angles are equal, and that's 90 degrees. Okay, so if these two are equal and that's 90 degrees, then this angle must be the same as that by similarity, AA. They are similar triangles because as long as two of the angles are the same, the third one must also be the same. So this angle must be the same as that angle, 30 degrees. That's why that's 30 degrees. Okay, So that's a little explanation, hopefully that was clear, of why the angle is 30 degrees. And in this case, this angle is going to be the same as this angle here, 60 degrees, for the same reason, for exactly the same reason. Okay, you're going to have a pair of similar triangles formed when you do the same thing here. All right, so that angle here, the angle between the weight and the reaction line of reaction force, is the same as the angle of the incline. Okay, so now once that's cleared up, we can now resolve the forces in the direction of motions of these two particles. So for x, I know I'm going to resolve the force up the plane because I know it's going to move up the plane. So for x, you've got the forces acting on it are the tension and the component of the weight parallel to the plane, which is 3g times, now you have to go away from the angle, so it's going to be sine 30. 3g sine 30, and this side will be 3g cosine 30, which we don't actually need right now. Okay, and here you've got 2g times, again, sine 60. Sine 60 because it's going away from the angle. You can think about it as we need, in this case, we need the side which is opposite to resolve this force, parallel to the plane. We need the opposite side. That's the, say, the hypotenuse. We need this force, not that force. That would be adjacent, that would be opposite. Or you can think about it in terms of, if you go into the angle, you use cosine. If you go away from the angle, you use sine. So that's 3g sine 30. So it's going up the plane. So t minus 3g sine 30 is equal to the mass, which is 3 times the acceleration, 3a, using F equals ma. So here we're using F equals ma. So we're going to have, as we mentioned just now, 3t is going up the plane. So this t minus, that's going down the plane. So that's 3 minus 3g sine 30. So this is the force acting up the plane. This is the force acting down the plane. The resultant of those two is going to be up the plane, which is the mass, which is 3 times acceleration, which we have to find. Okay, so that's an equation. Now I can just simplify that. I know that sine 30 is a half. So this is t minus 3 over 2 times g equals 3a. So that's one equation. And then I can also look at the particle y, which is going to accelerate down the plane in this direction like that. And in that case, you're going to have 2g sine 60 minus t equals ma. So you have 2g sine 60, 2g times sine 60 minus the tension is equal to its mass, which is 2 times a. And sine 60 is root 3 over 2. So root 3 over 2, the 2's cancel out. You're left with g times root 3 minus t equals 2a. And that's equation number 2. So if I take these two equations and I add them together, if I add these two equations together, the t's will be eliminated. You have t plus minus t. So you're left with these two added, which is going to be g times root 3 minus 3 over 2g is equal to 3a plus 2a, which is 5a. Now what we have to show is this. Okay, we have to take this and simplify it to make a equal this. So how are we going to do that? Well, what I'm thinking of doing is making this into one fraction. Okay, so I can make this over 2. So that will be 2 times g times root 3 minus 3g all over 2. And that's equal to 5a. And I can take out as a common factor of these two g. So I have g times 2 root 3 minus 3 over 2 equals 5a. And therefore I can divide both sides by 5. If I do that, I'll end up with exactly this. G over 10 times, let me write that a bit clearer, times 2 root 3 minus 3 meters per second squared. So that's exactly what we had to show. And there's the answer to part A. Okay, so we didn't have to worry about the reaction forces in terms of, there's no friction here, so I don't need mu, so we don't use F equals mu R. So I didn't have to worry about R. I just needed to resolve the forces parallel to the direction of motion and use those equations of motions I found to therefore find what A is. Okay, and show that it's what they asked us to show. So that's fine. Now for question part B, it says, by finding the tension in the string or otherwise, find the magnitude of the force exerted on the pulley. Okay, so now, here we have the two equations that we formed in the first part of the question. These were the two equations we formed from resolving the forces, and this was the acceleration that we found. Now we need to find the tension in the string. Now the tension in the string is 3 times A, so it's 3 times G over 10 2 root 3 minus 3 plus 3 over 2G. So that's the tension in the string. So the tension in the string is going to be given by, if we calculate this, you have 3 times 9.8 over 10 multiplied by 2 root 3 minus 3, okay, plus 1.5 G. 1.5 times 9.8. Okay, that gives us 16.0644. 16.0644 newtons. I'll leave it like that. Now, what I'm going to do here is that's the tension in the string. So let's just think about the forces that are acting. You're going to have basically a force acting in this direction. Make that a bit bigger. You're going to have a force acting in this direction and a force acting in that direction perpendicular to it. Okay, so you got this tension here, and this is the same value of the tension. So we're looking for the resultant of those two. We're looking for the resultant of those two forces. Okay, now what we can do is, because they're equal, because these two tensions are the same, then what we can do is we can realize that the resultant force is going to be exactly halfway between them. Exactly halfway between them. That's going to be the resultant force. That's the resultant force exerted on the pulley. It's tension pulling that way, tension pulling that way. So the resultant force is going to be exactly halfway between them. Now, if this is 30, this is 60, and this is 90 degrees, that means this angle here must be 45, and this angle here must also be 45. So a very simple way of doing this without having to use the sine rule or the cosine rule or anything else like that, which would be possible, or even trigonometry, is simply just to resolve this force going towards into this 45 degrees and also that one. So you got T times cosine 45 will resolve that tension going into the angle. And then you got another T times cosine 45 going into the angle there. Okay, and that will give you the resultant force. Simple as that. So that's 2T times cosine 45, which is 2 times T times root 2 over 2. The cosine of 45 is root 2 over 2. That leaves you with T times root 2. So the resultant force is T times root 2, which is the value we got there, 16.0644 multiplied by the square root of 2. So we take our answer and multiply it by the square root of 2, and we get our answer 22.718. 22.718 ... So we can leave this as 23 if you want. We can write it as 22.7, but that is the resultant force acting on the pulley. So there's the answer to part B. We could have also resolved the forces. We could say, okay, there's a tension acting in that way. We draw that force, then we draw another force acting in that way. Okay, that's T, that's T. We know that the angle between them is 90 degrees. We could have worked out what this force is. That's 90. And these two are equal, so that's 45 and that's 45. So we could have, worked out what this is. This is basically by Pythagoras even. You could have said that this is going to be the square root of t squared plus t squared, which is going to be it's going to be basically the square root of 2t squared, which is t times root 2. Same thing that we found there. All right, so you could have done it that way as well, and you would have found that this resultant force is t times root 2. So we find our t from earlier and multiply it by root 2. So there's a few different ways of doing this. Some by resolving forces, some by making a diagram. Okay, and we can get the answer to this question, part A. Now we need to find the other part of this question. It says find the angle that this force makes with the vertical. So what I'm going to do is I'm going to take this little diagram and just look at it a bit more carefully. Take it down here. We want to find the force that or the angle it makes with the vertical. So let me just make this a bit bigger. Now the vertical would be a line that goes straight down like this. This is the vertical. All right, now what I know is that this angle here is 90 degrees. And this angle here, therefore, is 30 degrees. Because that's 60, that's 30, that's 90. So we know that the force that's acting, the resultant force, is exactly 45 degrees from between these two. Okay, that's 90, so it's 45 degrees between these two, as we just mentioned. So I know that exactly 45 degrees between these two tensions, okay, is going to be the resultant force. All right, so that's 45 degrees. So the angle it makes with the vertical is the difference between 45 and 30. So you can say the angle with the vertical is equal to 15 degrees. And there's the answer to that question, which was part B of the question. So that's that's the resultant force acting on the pulley, and that's also the angle that that resultant force makes with the vertical. Halfway between them. Why is it halfway between them? Because this tension and that tension are the same, both sides of the string, on both sides of the pulley. Okay, that's part B. Now for part C. It says find correct to 2 decimal places the speed with which y hits the ground. Okay, so the speed with which y hits the ground. Now we know that the length of the string is 2.5 meters. All right, and we know that y is going to travel down there and hits the ground. So we know the acceleration that y is moving with. All right, so it's constant acceleration. So I think we're going to use suvat here. Now we don't know s. We can find s though, I think, because we have the dimensions of this, so we can find s. We know it starts from rest. We have to find what v is, and we know the acceleration is given. Okay, we know what the acceleration is, and I don't think we need the time. But what we need here is the displacement. We need the distance that it travels down until it reaches B, which you can find using this, basically this right angle triangle. This is a right angle. That's 30, that's 60, that's 90. So we can, if I call this length x, we can use trigonometry. We can say that the sine of 30 degrees is equal to the opposite, which is x, over the hypotenuse, which is 4. So therefore we can say x equals 4 times sine of 30. Now sine 30 is a half, so x is equal to 2 meters. So this is 2 meters. So I know s is equal to 2 meters. So now I can work out what I need to work out. We've got to use s and u and v and a. V squared equals u squared plus 2as, it seems. V squared equals u squared plus 2as. So we want to find what v is. So v squared is equal to 0 squared plus 2 times a. Now acceleration is g over 10 times 2 root 3 minus 3 times s, which is 2 meters. So if I just stick this all in my calculator and find the square root of it, I'll get my answer. So I'll take the square root of, that's going to be 4 over 10 g, which is 2/5 g. I'll just write it as 2/5 g. 2 over 5 times g, which is 9.8. And then I'm going to have times 2 root 3 minus 3. 2 times root 3, and then minus 3. Close that. That's going to be, yeah, that cancels with that, as we mentioned. So that's 2/5 times 9.8 times 2. Yep. The square root of that will give me v, which is 1.3488. 1.3488. So v to 3sf is 1.35 meters per second. Okay, that's the speed with which it hits the ground, and we can see that it does hit the ground. Why? Because the string length was 2 meters. So the length of the string is longer than that distance, so it will reach the ground. Okay, so there we have the answer to part C of this question, simply using suvat, and there's the answer, and that concludes this question from the Solomon A paper, which is question, I think it was question number 7 from Solomon A, and question 3 from my end of topic worksheet about forces and friction. Thank you for watching, and other questions from this particular Solomon A paper can be found in the playlist that should appear over here. Other questions from this worksheet, forces and friction, can be found in this playlist. Okay, the end of topic worksheet, and you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.